In this problem, we're asked to multiply two binomials. Just like we did with algebraic expressions, we can do this with radicals the same way. Using FOIL, F-O-I-L, we multiply the first terms together, square root of 2 times the square root of 2. We multiply the outer pair of terms together, square root of 2 times 5, or 5 square root of 2. The inner pair is 3 square root of 2. And the last terms are plus 3 times plus 5. Simplifying, any radical when multiplied by itself is just the radicand, 2. 5 square root of 2 plus 3 square root of 2 are like radicals, like terms. So we have 8 square root of 2, and 3 times 5 is 15. We can add the whole numbers, 2 plus 15 is 17, add 8 times the square root of 2. In this problem, we're asked to add two radical expressions. We got to get like radicals first. So for the first radical, we're going to split it into x squared, y to the fourth, which are the perfect squares, and the remaining piece is 3x. Continuing on, the square root of this is just xy squared for a total product of minus 7x squared y squared times the square root of 3x. For the second radical, we're going to break this radicand into x to the fourth y squared times 3x. The square root of in this radical is x squared y for a total product of x cubed y square root of 3x. That's a good answer because we're not really able to add the literal parts of this problem together because x cubed y is different than x squared y squared. Some authors like to go a step further and they can factor out the radical square root of 3x and in parentheses put the coefficients negative 7x squared y squared, add x cubed y. But it must be in parentheses, otherwise it's misinterpreted. Here we're asked to divide by a radical. One of the rules of radicals is leave no radical in the denominator. How do we get rid of this? This denominator is a monomial. The way we get rid of that radical in the denominator is to rationalize by a one factor. The one factor we want is the square root of 11 over itself. That represents 1. Now, when we multiply out the numerator, we have a binomial times a monomial, and I put it in multiplication format, square root of 11, parentheses, the square root of 10 minus 5. The bottom, as I said in another video, any radical when multiplied by itself always is the radicand 11. We can continue multiplying out the numerator. That becomes a square root of 110 minus 5 square root of 11 all over 11. In this problem, we're asked to divide out or rationalize the denominator. Note that the denominator in this case is a binomial rather than a monomial. To rationalize, we multiply by the conjugate. The conjugate is found by looking at the denominator and forming the opposite binomial. So 6 minus square root of 3, the opposite is 6. Well, I want to say opposite connecting symbol. So 6 plus the square root of 3 all over itself. When we multiply out the numerator, we have 33 parentheses, 6 plus the square root of 3. In the denominator, when we multiply the difference of two quantities by the sum of the same two quantities, watch what happens. Multiply out the first terms, we get 36. The outer pair is the 6 times the square root of 3. The inner pair is minus 6 square root of 3. Notice they cancel. That's why the rationalizing works. And when we multiply the last term, square root of 3 times the square root of 3, we get 3. So that the simplification is one more step, is the 33 in the numerator can cancel the 33 in the denominator, and we're left with 6 plus the square root of 3. Rationalizing when we have a binomial is a little bit more challenging, but remember the way to find the conjugate, it's always the opposite connecting symbol.